Okay, then well, let's think about one of the example, taking ethylene case. So as we studied, ethylene has two types of the bond. If we have a she, and there's double bond, and one bond is made of the sigma bond, the other is made of the pi bond. So in terms of the molecular orbital, you have sigma bond, sigma bonding orbital, and pi bonding orbital, and sigma star anti-bonding, and sigma star anti-bonding orbitals. So when we now simply think about the energy of electrons, if we have an electron in sigma bond, the energy is about approximated to be epsilon 1, and then in the case of electron in pi bond, it's equal to epsilon 2. Of course, this is just a simple approximation. The total energy of these electrons are 2 times epsilon 1 plus 2 times epsilon 2. Right? So when one of the electrons are excited, so but you can now simply imagine that there are many variations of how to excite this molecule, because so one type is like this one, but the other type is you can excite this one too. So when this one is up here, this is like this. On the other hand, if this one is excited, you can have this kind of electron configuration. Again, and then let's think about the total energy. In this case, still 2 of electrons are in the sigma bond, so 2 times epsilon 1, and 1 is epsilon 2, and 1 is epsilon 3. So in total, 2 times epsilon 1 plus epsilon 2 plus epsilon 3. On the other hand, if this electron is excited, the total energy is 1 epsilon 1 plus 2 times epsilon 2 plus epsilon 3. So you can see that this one is just this molecule is excited, but you cannot define the excited state without knowing where the electron from, right? So in this case, this one. In this case, this one. So in many cases, people confuse that the only thinking about the excited electron state, that only the electron in the excited state. But keep in mind that in the excited state, from where the electron is excited is also important, because the total energy is different depending on where it's from. And in this case, the electrons are coming from the pi state to pi star state. So this one is called the pi star state. On the other hand, if this case, electron is excited from this side to this one, it's called a sigma pi star state. And they have different energy. And also, you can simply imagine that electron is excited from, for example, pi electron to sigma star, for example, sigma star state. Sigma star state is something like this. So one of the electron is missing from pi bond to sigma star state. And in this case, from the sigma state to sigma star state. So electron configuration are different for these cases. And again, there's another important point of the excited state, which is multiplicity. As I briefly already explained, there are two types of excited state called a singlet state and a triplet state. And this is written like this. So this is written like this. So 1 and then 3. And also I've already mentioned how the the spin state of the excited electron decide which one. So when in the case of the excited electron spin is opposite to the original one, which is called the singlet state. And if this one is parallel, it is called the triplet state. So this comes from the point that the spin quantum state, As you've already studied, each of electron have a spin state, which is 1/2 or -1/2. Right? And the total spin quantum number for each molecule is the summation of each of the electron spin state. So in the case of the singlet case, in the case of the singlet, S equal -1/2 is from this one, and the rest of this is +1/2 and -1/2 equal 0. On the other hand, triplet state, the initial two of electrons are same, but equal 1. Depending on the total quantum number, there are several electron configurations. So the number of the electron configurations possible is given by the 2s plus 1. So in this case, in the singlet case, it's 1. But a 2s plus 1. In the case of triplet case, it's 3. So this how many variations you can have a configuration in the case of the total spin number. So in the case of triplet state, you have 3 variations of electron configuration. On the other hand, in the case of singlet case, you have only 1 electron configuration. That's why it is called a singlet or triplet, and they are different. They are different electron state. And also, one of the important things I have to mention is in the case of due to the Hund law, the energy is lower in case that electron configurations are parallel compared with opposite case. So always you can observe the energy in terms of energy, total energy. In the case T1 and S1 is always S1 is larger than T1.